Hey, hi everyone. Okay, we're going to take a quick look at this trigonometric equation here. Find theta in the domain provided and then you give a general solution. I chose this one right here because I like what it does. I think it's a good question because it covers a lot of outcomes. I think it's an excellent question. So first of all, again, I noticed that it's a trigonometric quadratic equation, but what I want to do here is I'm going to solve this in stages. I want to solve the algebra portion of this first. Now theta is an unknown. So is cosine theta. So I'm just going to let x equal the cosine of theta. So 2x squared plus 5x minus 3 equals 0. Okay, now this is not a cheat. This is actually an established trick in mathematics, is to represent an unknown expression with a variable to simplify the function down, or the expression down. Now I'm going to solve that. Okay, and that is substantially easier to work with than it is with the cosine in there, because we're far more comfortable because of Math 20 working with that. So it's going to be 2x and x, and I want my outer and my inner products here to add together to get 5. So looking at 3, we're going to get a 6 probably there. So probably a 3. So 2 times 3 is a 6. I'm going to subtract 1, so I'm going to make this positive negative 1 there. And there we go. Okay, now I'm just kind of guessing at it. That's what practice does for you. If you're having a hard time factoring, if that's still not something you're comfortable with, there's all sorts of methods that you can go to. I just ask your teacher and they'll help you out with that. So here, either 2x minus 1 is equal to 0 or x plus 3 is equal to 0, which means x is either 1/2 or x is negative 3. So that is the algebra portion of this. Okay, now we got to flip back to the trigonometry. Okay, and that's easy enough to do because x was simply the cosine of theta. So cosine of theta is equal to 1/2. Cosine of theta is equal to negative 3. Okay, now cosine is equal to 1/2. Cosine is positive. Okay, that occurs in quadrants 1 and 4. Now, once I've identified the quadrants that occurs in, I need to consider what the domain was, the specific domain of this function. This is a full rotation, 0 to 360. So that means we're going around the full thing. And I can see right now that that's going to give me 2 solutions, one in the first quadrant, one in the fourth quadrant. What I need now is my reference angle. Well, the cosine goes to 1/2 at 60 degrees. Okay, now whether you know that from the unit circle or special triangles or even using your calculator doesn't really matter, but that's what that is. So now I'm going to put that in quadrant 1. So the first quadrant angle will be 60 degrees. And then my fourth quadrant angle, whoops, sorry about that, is going to be, well, 360 minus 60, so 300 degrees. Good, so those are the 2 solutions, specific solutions coming from this particular factor. Now I got to take a look at this factor right here. And cosine of theta is equal to negative. Well, that's going to be in quadrants 2 and 3. But I'm not even going to write that down here because remember that the range of cosine is going to be -1 out to 1. Cosine never even gets to 3. So this is going to lead no solution. Okay, this factor here is a dead end here. And I like that. Okay, because if you understand what's going on, it actually shortens the amount of work you got to do. If you're not following what's going on here, well, that question's going to punish you a little bit because you're going to keep going here and pull answers out where there are no answers. So that deals with our specific solution right there. Now, to write it as a general solution is actually pretty straightforward. You just have to know that, like sine, the period of cosine is 360 degrees. So we might write our answer here as 60 degrees or 300 degrees plus n times 360 degrees, where n is an element of. Now I'm going to use the z here to represent integers. Okay, I know a lot of people use a capital I, but the more generally accepted term there is a z. Okay, so, and I know that a lot of times people will put a plus or minus right here, but if I'm allowing n to be an integer, well, n can be negative already, so that's would be redundant to put that in there. Although it's not incorrect, it is just redundant. So there's your general solution and there's your specific solution.